Okay, so this is one of the questions that would appear on the exam. God, blood. Alright. CH2, C, double bond, C, CH3, CH3. I apologize for my handwriting, but anyway, let's go. So this is what the question would look like. This is one of the examples of an anti-Markovnikov reaction that you will get on your upcoming exam. So you have peroxide present, which proves that this is indeed anti-Markovnikov. So this is an alkene that is unsymmetric. What does unsymmetric mean? That if you were to draw a line going down the center here between the two carbons, it is not a mirror image, because this is two hydrogens on this side, and on this side you have two metal groups. So this is unsymmetric. So unsim, I'll just put sim for short. So the first thing you would do, alright, let me just put this is an anti-Markovnikov reaction. Like someone said in the class last week, anti-Marky. So what does Markovnikov mean? Markovnikov rule states that when an unsaturated substituted alkene reacts with a hydrogen halide, the hydrogen adds to the carbon that has the greatest number of hydrogens. So for anti-Markovnikov, instead of the hydrogen adding to the carbon with the greatest number of hydrogen, you have the halide group adding to the carbon with the greatest number of hydrogen. This is anti-Markovnikov rule where peroxide is present. So for this question, let us get into how we're gonna do anti-Markovnikov with a B2H6 and a hydroxy group. So this is the peroxide present that justifies that this is anti-Markovnikov. So let's understand this a bit more. So step 1, you have a B2H6. What you would do in this step is you would separate the B2H6 or break it up into BH3, BH3. And because Markovnikov rule or anti-Markovnikov rule takes place with a hydrogen halide, you have to get one of these BH3s to look like a hydrogen halide. So what we're going to do is we're going to say, we'll put a hydrogen here and say that it's attached to a BH2, which is the same as saying BH3. But the reason why we did this was to get it in the form of a hydrogen halide, because this is an anti-Markovnikov rule. So now we're going to just using one. Don't worry about the other one. We're just using one. So we have a HBH2. So what happens here is that the BH2 acts as the halide group. So because this is anti-Markovnikov, what happens is that this, let me just change the color of the pen. This BH2, which looks like the halide group or represents the halide group, is added first to the side with the most hydrogens. Right? So it's added to the side with the most hydrogens because this is anti-Markovnikov, and the hydrogen is added to the side with the least hydrogens, or you could say the most R groups. So this is what happens. So I'll just kind of do it in the corner here. So what happens is that you get the BH2 added, and this alkene is no longer an alkene, it's an alkane. And then you have the hydrogen group added, and then you replace put everything as is, you know, the CH3, CH3. So this is what happens here. And then in the next step now, what you would do, remember that in step 2, they just showed that there's the peroxide present. So, you know, all you have to do is just know that this is present so that you know it's anti-macognitive. But what they wanted you to use here is the hydroxy group. So after you have this formed from performing the anti-macognitive, making the BH2 act as the halide group, adding it to the carbon with the most hydrogens, what you then do is you replace the BH2 with the OH. So this kind of somewhat looks, the OH now acts like a nucleophile. So then you have the BH2 acting as though it's a leaving group. So it leaves and the OH is now added where the BH2 existed before, and everything is the same from there. So this type of question, what happens is that you're really adding an OH and an H to this alkene. So you go from alkene to alcohol, but you have to go through anti-macognitive over here by, you know, adding an H and a BH2, and then after getting the BH2, this acts as the leaving group up here. So I'll just use a different color pen to show this leaves, and then you have over here, I'll just draw the arrow here, the OH replaces it. So this is it for this type of question. So you would get the question looking like this: an alkene, a CH2 double bond, CH3. It won't look like this. Of course, you'll get another question, but it will be an unsymmetric alkene, and you would have a BH2H6 in the presence of hydrogen peroxide, and hydroxy group, and so, you know, just pay attention, and this is what occurs. You separate BH3, and this is what happens. So what you need to do is just watch this video over a couple times, be sure to pay attention to the things that is taking place here, and you would get this full points. Alright, great.